Okay, so today we're working on lesson 1.5, which is least common multiples. You should have had this in your planner right away. Remember, that was the very first thing you should have done when you came to class. Our homework tonight is lesson 1.5 homework. It is in Big Ideas. It is only 10 questions. As I stated, I have a number of people that are having late work. I have your names down. I got to meet with you to let you know that you need to be coming to lunch detention. I'm going to have you come in and I'll work with you, help you if you need it. So if you're missing those, a few of you are supposed to come today. I didn't get to catch you. Your teacher was supposed to tell you they get ill. So I will meet with you today and let you know. I'll have your names down. So, lesson 1.5, our goal today is that I can find the least common multiple of two numbers. What this will look like today is if I ask you to find the least common multiple between the numbers 12 and 18, you're going to do something like this. I'm going to take 12. I'm going to take 18. Then I'm going to be able to go 2 times 2 times 3, 2 times 3 times 3, my LCM, these 2's, these 3's, and I'll get 9. Let's see, I'll get 4, 9. My least common multiple is going to be 36. Now, as of right now, you guys probably don't understand that, and that is totally fine. That's not a problem. But this is the work that you are going to be showing me today. The way that you are going to make this happen is 3 ways. 1, you are going to have to explain the meaning of what multiples are. And we're going to cover that in just a second. What are multiples? Second way, this is method 1. And it says use list of multiples to identify the least common multiples. So we're going to use list of multiples. Remember how yesterday we worked on, or the day before, we used list, you just glued it in your notebook. We made list of factors. Well, list of multiples is going to work the same way. And then the third way is use prime factors to identify. This is your second method. So method 1 really should not take us too long because this should be something that is, let's turn straight forward. Keep your feet on your own side, please. Listen forward. Put your feet underneath your own desk. It's already showing you can't do that. We're going to see that using a list is something that we've done in elementary. This is something you should have learned in 4th grade. I know I taught it in 4th grade. We did it on 5th grade. Nothing has changed. But I'm going to show you why we have a second method. Got it?
I'm just use the bathroom.
Is it an emergency?
Pretty much.
Okay, you got to fill out your plan and then I'll mark it down. Then I'll let you go. Alright. So, in our notebook, we want to do this. It says, work with a partner. We're going to create a Venn diagram. And we're going to identify multiples. Well, before we do that, does anyone know what a multiple is? What are multiples? Everett, what's a multiple?
Something that you multiply one of the numbers in a multiplication problem.
No, that's called a factor.
I forgot.
Mason?
Multiple is a number that you get by multiplying two numbers together.
Good.
That's the product.
Huh?
I thought that was the product.
And it is. It's like the product. Let's put the highlighter away and pay attention, please. So, a product, it's part of a multiple. Now, the difference between a product and a multiple is the product is a multiple when I'm talking about a given number. So if I want to put in my notebook just to help me, I can say ID multiples. And the way I do that is I'm going to times a number by another number. The only thing is this number in the blank has to be the same number. So if I ask you for the multiples of 2, I would say 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5. The answer, those are the multiples. That is the product of multiplication, but it's the product of a given number. Multiples are the products of given number. To help you, if you were to go into your big ideas, if you're ever confused on what something is, I'm going to go back into my first example. And you'll see, we're going to use this in just a second. It says key vocabulary. If I can click on that, it will take me to a glossary. And let's go to multiples. Multiple. The product, which is exactly what you were saying, Mason, of a number and any other counting number. So right now I'm going to ask you to find the multiple. You're going to find the answer to multiplication when you use a specific number and you can multiply it by any other number. Now the other way to think of multiples are like if I was to skip count. If I asked you for multiples of 2, we could skip count by 2. 2, 4, 6, 8, 10, 12, 14, 16. Those are all multiples of 2. So let's think if we know this real quick. What are multiples of 5? What could be a multiple of 5?
165.
Okay. Ends at a 5, so I know 5 goes into it.
265.
25. 565. 100. 365.
Good. Those are all multiples of 5. Now, how many multiples does a number have? How many multiples will a number have? When we did factors the other day, factors of 12, there was 1, 2, 3, 4, 6, and 12. There was 6 numbers that were factors. How many multiples are there of a number?
Like multiples?
A lot.
What do you mean a lot?
Like, what do you mean by multiples?
What we're just talking here.
That there are a lot.
What do you mean a lot? I need more.
Unlimited.
Why?
Because you can multiply it by any number to get a product.
Okay. Even if I was listing multiples of 2 and I went on for 84 years only writing down multiples of 2, when I get to the very last one, I'd be like, I'm done. I got them all.
No.
And then Patrick would walk up and go, hey, add 2 to that number. And I'd be like, ugh. Numbers never end. We can always add to them. So multiples will never end. So here's what I want us to do. I'm going to break you into groups real quick, and we're going to make a competition out of this. And I want to make this part clear. You're going to make a Venn diagram. Let's see. Okay. So Venn diagram, we did this the other day. I'm going to show just an example here. You're going to make 2 circles. I don't care if they're not quite the same size. And what your group's going to do is, I'm going to give you a number. Like on A, not everyone's going to do this, so I won't work ahead. But like 8 and 12. What your group has to do is you have to identify 4 multiples of the number 8. What are 4 numbers that if I skip counting by 8 I'd get to, or if I multiply 8 by a number I would get to? What's 4 multiples of 8? I need 4 multiples of the number 12. And this area in the middle are 2 multiples that are the same. Multiples that are multiples of 8 as well as 12. You're going to do the same thing over here. 4 multiples of 4, 4 of 14, 2 of the same. 4 of 10, 4 of 15, 2 of 10 and 15. 4 of 20, 4 of 35, and 2 numbers that I could get to by counting by either number. Okay? So, let's do this. I'm going to come around, I'm going to give you a number, and I want you to put your number up in the air. So, you're a 1, you're a 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, count. 4. 1. Okay, if you're a 1, put your hand up in the air really, really high. Wave it around. If you're a 1, look around so you see who your team is. Okay, if you're a 2, put your foot up in the air. Kick it. Who's all my 2s? 2. Okay, 2s, we'll go together. 3s, I need you to bobblehead for me. Who's my bobbleheaded people? Okay, 4s, wiggle in your seat. Alright, so here's what you're going to do. If you are a 1, you are doing D. If you're a 2, you're doing C. If you're a 3, you're doing A. 4s, you're doing Bs. Your whole group has to have this done. You may move around the room. Go find your partners. Go talk about these. So, group 3. Who's in group 3? Alright, so let's look at yours. Alright, so what were 4 multiples of the number 8? Talon?
8. 1. Oh no.
1 would be, because that'd be a factor. Bethany?
28. 16. 24. And then 32.
Okay. What would be 4 for the number 12? Anastasia?
12, 24, 38. I think it was 50.
It would be 38. I think you guys made a little mistake. Should have been 36,
6.
which then if you had 12 to that would have given you 48. What would be 2 numbers that they have in common? Maddox?
Yeah.
24. Like we can see right here that 24 was listed twice. So 24. What would be another one?
And 48.
It would be 48. This 48 here would end up being over here as well.
After 40.
Okay. How about group 4? What were my factors? Multiples of 4, Mason?
8, 12, 20, 24.
How about for 14? Peter?
42, 70, 98, and 126.
Okay, what would be in common? Sky?
28 and 56.
28 and what?
56.
Okay. 20 and 56. Good. How about 10 and 15? So this is group 2. Draylee, how about for 10?
10, 1, 30, 40, 50, 60.
Okay, good enough. That's 4. How about for 15?
45 and 60.
And what can I put in the middle? Alex?
60 and 30.
Yeah. 30 I see on both. And 60 what? Okay, how about 20 and 35? Sarah, what about 20?
20, 40, 60, 80.
How about for 35? Maddox?
I got 70, 105, 210, and 225.
70, 105.
210 and 225.
Okay. What about the shared ones? Sarah?
140 and 280.
Okay. Now, if we look at these two, or 2, 4, if we look at these two numbers and we're comparing them, we can see that we have multiples that stand alone, that when I count by the number, I only land on that number by it, like on 8 and 12. 8, 16, and 32, I'm not going to hit those numbers if I'm counting by 12s. But 24 is common. Let's look at the ones I put in the middle. Oh, that's the second group on B. I'm sorry, I didn't write your 20 and 56 in right. Is there any relationship between our common numbers? I have 24 and I have 48. I had 28, I had 56. I had 30, I had 60. I had 140, I saw 280. Is there any relationship? Marley?
They're all even.
Okay, they're all even. That happened to be a coincidence. They wouldn't always have to be that. Everett?
Plus times 2.
Explain that a little bit more.
Alright, so 24 times 2 is 48. 30 times 2 is 60. So you have one multiple, you times it by 2 and it will be a multiple again.
Alright, good. If I ever find a multiple, I will have, or if I ever find a common multiple, it also means I have unlimited common multiples. Because if I take a multiple of 24, and that's a common multiple, and the both numbers go into 24, if I take that 24 times 2, that number will become a common multiple as well, because it's like, I did my two numbers to get to 24, and then I did my two numbers to 24 again. So we get an unlimited. I got a big question for you though. Does every set of numbers have a common multiple?
Eventually.
Well, don't shout out your reasonings yet. But 21. Okay. Do these two numbers have a common multiple? Yes or no?
Yes. Probably. Yes.
Julie, what do you think? Does 71 and 3,421 have a common multiple? What's your initial feeling? Okay. Patrick, what's your initial feeling? Yes or no?
Yeah.
Okay. Alex, initial thought right away. Yes or no? Do they have a number in common?
Yes.
Marley? Maddox?
No.
Sarah?
Yes.
Mason?
I don't know. I don't want to do the math.
Ooh, that's actually a good explanation. Bethy?
Yes.
Everett?
Yes, but I wouldn't do the math.
Okay. Now I look at it, and I'm going to say my initial reaction when I first looked at it was no. And then when you start to think about it, it's, well, no, I don't want to do the math. The way we know how to find least common multiple is the very first example we're going to do. We list them out. And that's what a lot of you guys did when you did your Venn diagram. I saw it. You got the calculators out. You said, okay, 12. Okay, 12 times 2 is 24. Okay, times 3 is 36. Times 4 is 48. Or you just did repeated addition. 14. Okay, 14 plus 14 is 28. 28 plus 14. You did the work. Okay, that's 42. And we had to do that. And that's hard. If I did this one, 71. I'd have to keep doubling, tripling, quadrupling. If I did that. So, I need to know, yes or no. and I need you, and I need to be convinced. Right now, I don't believe you. Either way, if you tell me no, I don't believe you. If you say yes, I don't believe you. You have to prove it to me. Sarah.
So, can I say what?
Sure.
Okay, so yes, because
Are you positive?
yes,
I don't believe you.
I'll tell you why. So, every number is gonna have something. They're gonna have a common multiple because you can times them by each other, and they're gonna have multiple common multiples because once you do 3,421 times 71, you get your product. Then obviously know 71 can go into that number 3,421 times, and 3,421 can go into that number 71 times. But you can just multiply that product that you just got by multiplying them two. Just multiply them by 2 again, and then just double each number.
Perfect. So, do my two numbers always have a common multiple? Simply put, why? What did Sarah just tell us? This will show me if you were listening, because I got a feeling some of you weren't. This is why you're struggling in math or you're not getting your homework done, because you're not paying attention during class time. Maddox, why are these two numbers have a common multiple?
Because she said that you could multiply 20 and 35 to get a common multiple.
I can multiply what?
20 and 35.
I'm going to multiply what? If I'm comparing 71 and
I'm
3,420.
not talking about only those numbers. I'm talking about like the two numbers.
Oh, any terms, yeah. So you can multiply any two numbers. Everett?
But
Sure.
like, if you multiply 71 times 3,421, would it be the least common one?
There you go. Now you're getting a good question. So 242,891. 242,891. Alright, so when I multiply these two numbers, I would find my common multiple. 242,891 is a common multiple. We know it because 71 will go into that number if I skip counting by it 3,421 times. 3,421 would go into 242,891 if I skip counting 71 times. So if we only learned method 1 today, which is making a list, you would have to write down 71, and I go 71, 142, 313, and I have to do that 3,421 times. Is that going to be effective?
Yes. No.
You want to do that for your homework?
That'd
No.
be
That's what we're going to learn the second method. What we do with larger, more complicated numbers. Now, Everett asked a great question. Is this the least common multiple? It might be. It might be,
how do you know?
but I don't know yet. If I use method 2, I would know for sure. And so we could look at that here in a little bit. Maybe we'll come back to this one. Yes.
I actually know what you could do. Since the last number is a 1, it can't be divided. In this, I think what you would do would be see if you could divide by it a number, and then like
Kinda. You're going to see, I think what you're kind of saying is going to match up with method 2. So, what I want you guys to do is just put this stuff to the side, and let's look at our notes. Ethan, will you give notes to that side of the room? I feel like I'm short on notes for some reason. Should be. Yeah. I'm not making that mistake again. Ethan, are you running thin on notes?
Oh, yeah. Can I use the pencil sharpener?
Did you have enough, Ethan?
Yeah.
Alright, let's look at our notes. We'll get started right away. Names should be on your paper. We are for silver. Today is 9/11. Alright, first thing I want to look at is our vocabulary. Now, we already identified multiples as the product of a given number and any other number. When we look at common multiples, we're going to do this where I'm looking at my big ideas and I click on that vocabulary word and it tells me common multiples are multiples that are shared by two or more numbers. So I'm going to say multiples shared by two or more numbers. Okay, well that makes sense. A common multiple means it has to be like the same multiple between more than one number. I have to find the multiples of one given number. I have to find the multiples of another number and which ones are the same. The next easy term is least common multiple. What's least mean? Smallest. So all we have to do is say what's the smallest common multiple. Now here's the funny thing in math. We always kind of try and write our stuff down smaller. So we use other vocabularies. Here's the crazy thing. Least common multiple, I guess I could write the smallest same product of two numbers that is shared by more than one number. Like, I could have started explaining what multiple is and what common is, but we expect you to know one word and then we use it to build another one. You have to know what a multiple is to be able to identify a common multiple. I have to know common multiple to identify a least common multiple. You can go quick, we're taking notes already. So, this is the important part. Knowing what these are. Now, here's a cool trick for you guys today. Today we're going to show the first example, and then I'll show you the shortcut to it. But, example 1, if you want to underline this, example 1 is using the list method. I refer to this like in elementary. This used to be my go-to, and the sad thing is, I never really used method 2. But the more I'm looking at, the more I like it, and I don't like this method anymore. This method I don't think is the most efficient way, and I think I'm always bored with it because there's too many rules that aren't really applying to it. And you'll see why. Using lists. Now, if you look, you have to show me 4 pieces of work. I'm going to ask you, what is the least common multiple of 4 and 6? This is how you do it. On line 1, we write multiples of 4. The most important thing is that we do this in order. When we did factors, we could kind of do factor pairs however we wanted to, and we could get least common multiple. We have to start at the bottom. We have to get the smallest ones first. Now, my rule, I always told my students, was start off with 5 multiples. And I think this is why I don't like this method as much, is because do I have to do 5? No, I might have to do 10. Might have to do 2. There's too many unknowns. Here, I need you to put that away so you can do your notes with me, so I don't have to mark your planner. So, I'm going to list the first 5 multiples. So I'm going to look at the number 4, and I'm going to say, okay, 4 is always the first one. 4 times 1. If I times it by 2, I'd get 8. Times by 3, I'd get 12. Times by 4, I get 16. Times by 5, I get 20. Or I could say I skip counting by 4. 4, 8, 12, 16, 20. My second line, I'm going to go ahead and I'm going to do the same thing but with the number 6. I'm going to skip count back. 6, 12, 18, 24, and 30. Now when I look for common multiples, I look at my list and say, what multiples did I write down twice? 12 was written twice, and that's it. So my common multiple is 12. So does that mean the number 4 and 6 only have one common multiple, and it's the number 12?
No.
What? I don't believe you. That's so fun to say. And then you go like, hey, bring it around. Marley?
It's not because it's only telling me to list five multiples. There are way more multiples than that.
I don't believe you. You have not proved me wrong yet. All you've done is make a statement that there's more of them. I don't believe you. Can you prove me wrong? Or can you prove your point?
Yeah.
How?
Because numbers are unlimited.
Can you prove it to me? I still don't believe you.
Because if you write another 4 to 20, it'll be 24, and then you have.
There we go. This is what I'm going to keep getting at you guys all year. Maybe you guys didn't have this in elementary. Your teacher was like, okay, I believe you. I'm going to tell you I don't believe you because one of the things I see on tests, on quizzes, on NWA, on math testing, they ask you for an explanation and you go, because there's more of them. That's not proof. You have to prove it to me. Marley just did that great. She said numbers are unlimited, and then the best part she said is, if I do the next multiple of 4, and I'm going to do this in a different color because we didn't have it listed, I'd get the number 24. Well, 24 is an example of a common multiple that would have been listed. And we can continue on. And then she said there's unlimited amounts of common multiples because my numbers can continue. She's absolutely correct. The phrase that a lot of students used in my last class was, they said 12 was the only common multiple in our current list. And this is the part that makes me I don't like it because there's not set rules. Because I could write 5 out, I might get one common multiple. If I wrote 30 numbers out, I might get multiple.
Yes.
Right now, well, hey.
Oh, hi.
Right now, I'm going to ask you at least list 5, but I'm going to show you on the next try-it how we can adjust this. A couple of different strategies for the first method. Now, of my common multiples, what's my least common multiple? Marley? Yeah. That's my answer. Here's the nice thing about least common multiples. If you're doing this in correct order, the very first common multiple you find is your answer. So on your homework tonight, if you're doing this, do you really have to list out 4 common multiples? No. If you find the very first one, you're done. Stop. Write it down. That's your answer. Okay? Sarah?
Just like, if you have 12, and then 12 plus 12 equals 24, so you already know that 4 can go into 12, and that 6 can go into 12. If you just add 12 plus 12 and you get 24, you automatically know that's just giving you more common factors. You can just keep adding 12 plus 12 plus 12, and they're common multiples because you already know that they can go into.
Totally.
You can't use.
Now, I love this because I was like you. I caught on to this, and I remember in school learning that. And our teacher was making us. She actually took points off. My teacher was really strict. I got points off because I didn't show all my work. When they did lists, we needed to write all the lists. But she told us we had to find like 4 common multiples. Well, just like Sarah was explaining, well, if 4 and 6 go into 12, let's say they go in, this goes in 1, 2, 3 times, this goes 1, 2. Well, if I need another group of 12 and I did another 3 or 4 and another 2 of 6, that means 4 would have went into 24 6 times. The 6 would have went in 4 times. If I take my least common multiple, and here's the crazy thought. If I take my least common multiple, we identified as 12, and I list the multiples of 12. So I'm going to list the multiples of my least common multiple. All those multiples become multiples of my first 2 original numbers. Because it's like, if I list these out, 24, 36, 48. It's like I need 3 4s, 2 6s. I need another 3 4s, 2 6s to add to that. I'd do another 3 4 and 2 6s, and another 3 4s and 2 6s. Until I get like 3 4s, 6 4s, 9 4s, 12 4s. All we're doing is skip counting by that and building on it. And that's where I got in trouble because my teacher, I feel like, hey, I was showing advanced thinking. I totally understood the concept. I just didn't do the paperwork. But I did the same thing, and I even went, because I love finding cheating ways, I always took everything times 10. Because times my 10 is simple. Mr. Berg asked me one time, "Oh, Mr. Cecil, smart aleck, huh? Go ahead, list up. I want you to list 10 factors and not factors, multiples, common multiples." Because I told him, dude, this is so simple. Smart aleck. You always call me Mr. Cecil when you got in trouble. That's how you knew you had on his nerves, which is we kind of keep pushing, see how mad we can get him. Which was stupid.
Okay.
It was bad. Yeah. Mr. Berg, oh, Mr. Cecil, smart aleck, huh? Okay. Okay. I want you to list like 10 factors, or 10 multiples of the number 12. That was like 12, 120, 1,200, 12,000, 120,000, 1,200,000, 12 million, 120 million. I just added a zero in the place by. I just moved everything over. It wasn't the least common multiple. It wasn't a multiple. It wasn't a multiple. It wasn't multiples in order, but that's not what the instructions were. Are those all multiples? Yeah. I just took it times 10. I could have went in order by identifying my least common multiple and then just the multiples of that. So this is why math builds on each other. Alright, we're going to do 2 more examples and we're done with this first one. Okay? This is elementary. This should be easy to do. This should just be a refresher, this first one. Here's what I need you to do on your notes for me. I want you to show this work. I want you to list the first 5 multiples of 3, first 5 multiples of 8, and then tell me, are there any common multiples, and what is your least common multiple? When you're done with those, come over here, and we're not going to do number 2. We're just going to stop there, and we'll get to number 3 in just a second. Okay, I'm going to pause real quick. I want to see what you can do at number 1. Huge hint, there's going to be discussion on this one. All right. What are my multiples of 3? What's my first 5 multiples? Sarah?
3, 9, 12, 15, 18. 3, 6, 9.
There we go. Count by 3. 3, 6, 9, 12, 15. First 5 of 8. 8, 16, 24, 32, 40. Now, here's why I'm going to talk to you on this one. If I went ahead and listed the first 5 multiples, do I have any common multiples? Also, am I done? There is no least common multiple. No, it just means I haven't got to it yet. Now, I heard a teacher before that said, okay, you have to extend each one by 5 more factors. Well, not really. Or multiples. I keep saying factors. Multiples. Here's what you can do. Take your smaller number, okay, the number 3, and I'm going to look, is number 3 listed in these multiples? No, so I'm going to cross it off. Is 6 listed?
No.
Is 9? No, but now do you see how 8's less than 9? So I'm going to take that off the list. Is 12 listed? Is 15 listed? Now I'm out of those multiples, but look, I still have 1, 2, 3, 4 multiples of the number 8. So if I'm showing my work, I don't really have to add a bunch of multiples to 8, and I'm not going to add a bunch to the number 3. I'm just going to add 1 at a time. So after 15, my next multiple would have been 18. Is 18 listed? Okay, but 16 is less, so I know that's not going to be an answer. 18 wasn't, so after 18 comes 21. 21 listed? No, so I'm going to cross it off. After 21 comes
24.
Is 24 listed?
Yes.
Because that's listed, even though that's the very first one I found, I can stop. And I don't really have to do the common multiples. I can just go straight to my... Don't know why I'm deciding to draw this circle. Maybe I don't want to make a happy face. What? I'm just going to go right there and identify my least common multiple was the very first multiple I found, which was 24. Okay, I'm going to show you how you can use this on this next one. Because there's a couple methods we could do. When I'm doing a list, I can also do this. I have the number 6 and I have the number 10. Now, what's special about the number 10?
It just goes to.
Yeah, but what's special about every one of its multiples?
They all use
They
zero.
all
They all use zero.
They all end zeros. So, if I listed the multiples of 6, can that be a multiple of 10?
No.
The very first multiple that is shared between 6 and 10 has to end in a 0. So I'm just going to go 6, 12, 18, I'm skip counting by 6s, 24, 30. Hey, that ends in a 0. If I show my work down here, I'd say 10, 20, 30. My least common multiple is 30. Now this seems pretty simple for you, right?
Yeah.
So I want to do this real quick. I messed up on my notes and I copied this. Go ahead and just scratch this part off. And I'm going to do this. With the infinity ball, can you identify the least common multiple for me?
Yes.
The number? Ethan, alright, Liza, pay attention.
That's a least
Alright. I swear I'll
Yes,
get
that's
it.
why.
Alright. Who can tell me what is the least common multiple between 2 and 3? Least common multiple between 2 and 3. Alan? 6. Good. How about between 2 and 4? Maddox? 4. How about 2 and 5? Patrick? 10. How about 3 and 4? Effie? It'd be 12. How about 3 and 6? It'd be 6. How about 3 and 7?
Go
21.
21.
How about 4 and 8? Between 4 and 8. 8. So these are pretty simple, right? To be honest, what most of you are doing in your head when you're getting the answer is method 1. You're listing the factors. You're just doing it really quick because you know your math class. When I did 3 and 7, the one class, I loved it because one person did a think aloud when they come and they go, okay, they have 3 and 7, they go, okay, 7, 3 doesn't go in there, 14, 3 doesn't go in 14, 21, 3 goes into 21, so it's 21. They listed the factors. Or factors. They listed the multiples. Gosh, I can't believe I keep saying factors. They were listing the multiples and then just comparing them as they went. That is what we could easily be doing if I said, what is the least common multiple between 5 and 6? I would simply just say, okay, here's 5, here's 6. And I do 5. Does 6 go into 5? No. 10. No, 10 divided by 6 is not even. 15. No. 20. 25. 30.
Yes.
Yeah. 30. And I know 6s. I just know it's going to be boom, 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 boom. Even if I didn't identify every multiple of 6, I know for 5 that was the first one because I was checking it as I went. So if you're using this method, that's why a lot of people are like, oh, this is too easy. Okay, what is the least common multiple between 28 and 35? Oh, I need the answer.
Oh, I don't have time to write it down.
Okay, write it down. Try to find it for me.
Wait, what's the numbers?
28 and 35.
Hey.
7's a factor.
6. 2 is 8.
Nope. Multiples, not factors.
980.
That's a multiple. Is that the least common multiple? You just multiplied the two numbers, all right?
No, it is
980.
400.
Are you positive? Would you be willing to bet me a week's worth of lunch detention?
Lunch detention.
Oh,
Yes.
You will?
490.
490? All right, let's find out.
Oh my goodness. Busted.
So, what we are going to do is we're going to check his in just a second. So we said the numbers was 28 and 35.
Yeah.
Okay. We'll come and check his answer of 490 in a second.
No, I changed it. I changed it.
I want to change it. Okay.
Okay, turn your notes to the next page. Here's how we're going to find this. The second method is a method that you have to end up deciding. I need you to try and face this way. The board is this way, not back there. Turn around so you can face it, please. The second method is with prime factorization. The reason we use this method is so I don't have to list multiples. A number of multiples. Now, the first two steps of this is very, very simple. So I need to make sure you're following so you understand it. The first step is simply to make a factor tree. So I'm going to do here 16. To make a factor tree, I'm going to do 16 is 2 times 8. 2 is prime. I'm going to make 8, 2, and 4. 2 is prime. And 4 becomes 2 times 2. I need you doing this. I'm going to be marking this off for you. For 20, I'm saying 2 times 10, 2 times 5, and they are both prime. Okay, so that is all I have to do on the very first step for this second example, how to use prime factorization. I just make a factor tree of my two numbers. Pretty simple. The second step, and this is where I want you to do this exactly like me, this will help, is I want to write the prime factorization of each number. So I'm going to go down here and I'm going to say 16 equal, and I'm going to write my prime factorization, the prime numbers I use. 2 times 2 times 2 times 2. That was all these listed right there. I'm then going to write the prime factorization of my second number, which was 2 times 2 times 5. So far, nothing different. You actually had to do this for homework already. Here's where the change comes in. And this is where I want you to pay close attention. What were the prime numbers used? Marley, what prime numbers did I use? Alright, so I'm just going to write them to the side. 2 and 5. Okay, here's the trick. I have two numbers with prime factorizations. I wrote mine color-coded to help you. A blue and an orange. I can only take from one group at a time, and once I take a number from one group, I lose the ability to take it from another group. So it's kind of like if Jude was going trick-or-treating, this guy said, I have this bucket and I have this bucket. And there's 4 2s, 4 Twixes in this bucket, and there's only 2 Twixes in this bucket. Which bucket do you want to take?
2.
And if he reached in and took the 4 out of this bucket, these 2 he cannot have anymore. They go away. Okay? That is what we have to think of. So, here's how you do this. The prime numbers I used were the numbers 2 and 5. Okay? I'm going to write underneath here LCM. My least common multiple. The first prime number we are going to look at is the number 2. Now, which number, 16 or 20, did we use more prime number 2's in? In what?
16.
That's a lot. 16. How many 2's did we use in 16 then?
4.
I'm going to circle all 4 of them. 1, 2, 3, 4. Now, if I take those 4 2's, I cannot take them from the other group. I can only take from one group. Those 2's all go in my LCM. 2 times 2 times 2 times 2. The ones I circle go in my LCM. You copying this stuff down, Patrick? Okay, I'm done with the prime number 2. The other prime number we used was the number 5. Okay, did 16 or 20 have more 5's in it? 20, because 16 didn't have it. How many did we have in 20?
1.
So I could only circle 1. So I put one of them here in my LCM.
Wait, what?
Yes.
So,
Well, that makes sense.
so how did you decide, like, which number to put on top, like, of 16 and 20?
It doesn't matter.
But
You could definitely do it.
what if you would have put, like, 20 over the top of 16, and there, you looked at 16, and there, so you picked the one that has the greater amount of the number?
Yep. You take the one that has the greater amount in it.
I thought.
Okay? I now multiply all this. And if I need to, I use my calculator. And I do 2 times 2 times 2 times 2 times 5. I'm stopping in the middle of now to talk to you about this. And I would get 80. That means 80 is my least common multiple. Okay? We're going to do a few examples. We're actually going to do 2 to 3 because we got to throw in Everett's here in a second. So let's try this again. Let's try this again. On number 4, the triad. I need a first on each one. First step is to make the prime factor tree. Ethan, I need you to turn and face forward. If I have to find a new spot for you, I can. But right now, you turn facing the back of the room shows me you're not involved with math. Okay, 14. I'm going to make my prime pairs. 2 times 7. And I am done. That was simple. 18, I'm going to do 3 and 6. 6, I break up to 2 times 3. Done. Okay, what was my second step? Peter? Yeah. What's my second step? Riley, what do you think I do next? I made my factor tree. What did we do next up here? I made my factor tree and then I did what? Huh? What did you say? Yeah, this part, right? That's called our multiplication problem, right? So, next step is, I'm going to go ahead and I'm going to say 14.
Oh, gosh.
It's okay. You see, but
Wait, are you actually going to take a call on that?
But I will take it.
Wait,
I'll take it. Is that the correct answer?
I don't know why this all moved. There we go. Alright. So, I'm just going to go ahead and I'm going to write this down. My prime factorization of 14 was 2 times 7. My prime factorization of 18 was 2 times 3 times 3. Okay, here's the new steps that you probably have not learned yet. I first identified what prime numbers did I use. I'm going to write them off the side just to stay organized. I used what numbers?
2, 3, and 7.
2, 3s, and 7s. Alright. My LCM, my least common multiple, will be, okay, I'm going to look at the number 2. Do I have more 2's with the 14 or more 2's with the 18?
Equal.
They're equal. Since they're equal, it doesn't matter. I just take from one. I can only take from one group. So I'm going to take the 2 from the 14 and say, sorry, 18. And I put that 2 in my least common multiple. I am done with the 2. I have to look at my prime number 3. Draylee, did I have more prime 3's in 14 or 18? 18. How many do I have in 18? Huh? How many 3's? 2. 2, 3, 3. So I'm going to say those 2. And I put them in my least common multiple. I'm done with 3's. I go to my 7's. Alex. Which one had more 7's, the 14 or the 18? How many were in 14? So I put in my least common multiple. I'm done with the 7. Now that I've identified all my prime numbers, we multiply. And if I use my calculator to help, I could simply write 2 times 3 times 3 times 7. 126. The first common number is 126. If we would use method 1, I would have been skip counting by 14 9 times. I would have skip counted by 18 7 times. So still not that big of numbers. Okay, let's cross these two numbers off. And let's do 28 and 35.
I changed my answer.
I can't. You were so sure. You already made the bet.
And then I.
So, first thing, we're going to make our factor tree of 28. What is a factor pair for 28? I'm going to do this quickly for you. 2 and 14. 14 I'm going to make 2 times 7. I'm going to go ahead and, draw my boxes. I'm going to say 28 is 2 times 2 times 7. For 35, 5 times 7. Ooh, that's pretty easy. 35 is 5 times 7. What prime numbers did we use?
2, 5, 7.
So we would write down 2, 5, and 7. Okay, now it's time to find out which ones to use. For the number 2, raising your hand, did I have more 2's listed with the 28 or the 35?
28.
Okay, 28. How many did I have? 2 of them. So my least common multiple would be 2 times 2. And I'm done with the prime number 2. We look at the prime number 5. Which one had more?
35.
Anastasia?
35.
35. It only had 1, so we put 1 in there. We go to the 7. What do I do? Don't shout it out. What do I do when there's a tie? There's 1 in 28 and 1 in 35. Marley? I choose only one of them. Can't use the other one. And I'm done. We multiply. Well, 2 times 5 is 10. And 2 times 7 is 14. 14 times 10 Bon appetit.
Bon appetit.
Tomorrow.
Wait,
So,
I thought that was a joke. Wait, I was joking. 5 days.
how was it?
Thursday through Thursday.
I'm eating with it.
Was it
So-
good?
Can I still look at lunch attentions with them?
No.
Can I have one?
Alright,
But that's what a good twin does.
son.
What?
That's not
Alright,
close enough. No.
gentlemen. Now you're just stealing time. Hey, this is the methods that you're going to be using today. One thing I'm not going to spend much time, I might already discuss, is what if there's 3 numbers? Nothing changes. Okay? If there's 3 numbers, you still make the factor tree like they did here, and they said the prime factorization of 4 was 2 times 2. Of 15 was 3 times 5. Of 18 was 2 times 3 times 3. They just did the prime factorization like we did with 2 numbers. However, now they said the prime numbers we used were 2, 3, and 5. And for 2, well, there was 1 2 here, but 2 here. So they used 2 2s. This one's gone. 2 2s in my least common multiple. We looked at the number 3. There's 1 3. 18 had 2 3s. 2 3s was more than 1, so don't use that one. And I used 2 3s here. For the number 5, there was none. There was 1. There was none. So I used 1 5. That's all you're doing. The biggest thing is you have to write the prime factorization, and then you have to take those and identify which prime numbers use the most for which number and put that in your least common multiple. Okay? Now, you have 5 minutes to at least start. Your homework's 10 questions long. Before you start, I should not have people up, moving around. Should not have people talking. You must be turning your homework in. Your work that is not done, you owe me lunch. Because we have to. Oh, I still got people talking. Your homework. So I'm getting people to turn in. You must be putting your heading on. Your name. The date. The lesson. Oh, Alex, why are you up walking around? All you're doing is saying, Mr. Sissel, I hear you talking. I don't care. I'll do my own thing. Your name. The date. The assignment. And what class are we? Okay? You may begin.